Hey guys, welcome to another video. This video is going to be about solving proportions. So a proportion is just a way of saying two fractions that are equal or two ratios that are equal. So don't need to write this down, but a ratio, and it's not working. A ratio is just a fraction. And a proportion is when we say two fractions are equal. And as we know, when we're setting two things that are together that are equal, we can do a lot of things with that. We can solve if something is missing sometimes, and we can find that missing information. So it's two fractions that are equal. So we're going to just practice solving some. You've probably heard this before, but it'll be good practice. So say this would be sort of a simple example of a proportion. There's just one x, and they just want us to solve for x. So just like the common theme for this whole chapter, we just want to, at the end, be able to say x equals something. In this case, it's going to be a number because there's only one x in this whole thing. There's no y's or anything. So what we can do, I want to illustrate kind of what's happening before I do this. So say we didn't know about a trick of cross multiplication, which is what we'll get into next, but say we do know how to what's called bust fractions. You guys may have heard. I like to think of it as destroying fractions. But if I wanted to make this not a fraction, 'cause most people don't like fractions, and fractions do make things difficult in math, I would multiply both sides by 40. And that would destroy this fraction over here. 44 divided by 40 multiplied by 40 is just 4. So that's what's called fraction busting, multiplying by the denominator. Now this side, let's just write it like this. 40 times 8x over 2. Now what we kind of want to do is we also want to bust this fraction. So we would also multiply this side by its denominator multiplied by 2. So now we have 4 times 2 equals 8x times 40. Let's put it over here. So we have 40 times 8x equals 4 times 2. And you can see that here. Do this in red. 2 times 4 equals 8x times 40. So this idea of cross multiplication, it only applies when we have an equal sign. We're not actually figuring out the product of these two fractions, which is why a lot of teachers don't even like saying cross multiplication, because students will confuse it with actual multiplication. This is just a kind of shortcut way of busting this fraction and writing out an equation like this. So what we're really doing is we're busting that fraction, writing out this equation. But we can think of it this way. 8x times 40, or 40 times 8x. And what would that be? 4 times 8 is 32, right? So 320 equals 8. Where'd the x go? There's the x. And now we would just divide both sides by 320. So we get x equals, let's go ahead and simplify. So x equals 8 over 320. Well, 8 over 32 is the same as 1 over 4. So this is the same as 1 over 40. And this makes sense, because this number's got to be really small, because this is only 4/40ths. So this also needs to be 4/40ths. One thing that you can do that I didn't mention is you can simplify each fraction before you start the cross multiplication. So right away, 8x over 2, let's just leave that as 8x over 2. 8x over 2, we could simplify this, but we could write that as 4x over 1 equals 1/10. That's going to make your multiplication much easier, but you would solve it the same way. All right, let's try another one. So a huge place where proportions are used is in geometry. So similar figures, two polygons that are similar, one part of them being similar is that their sides are proportional. And their sides are proportional in this way. Say they tell you that these two rectangles are similar. That means they have all the same angles, all 90-degree angles, so that's pretty easy. But their side lengths will be proportional. So for instance, if the width of this one is 4 and the width of this one is 2, there's sort of a 1/2 relationship going on here. Then say we know this is 3, then this has to be 6, because it also has to have that same 1/2 relationship. In other words, we could solve the proportion 2 over 4 equals, let's change these values. You'll definitely have some tests in geometry that'll just be, this will be a huge portion of it. Let's say that that's 8. So I want to write 2 over 4 equals 8 over x, because we got to stay consistent. We want to do the smaller one on top. So we could solve this. We'd get 2x equals 32. Divide both sides by 2. We get x equals 16. So if you can do, I told my students this last year because I taught geometry, if you could do proportions, you could get at least half of the points on the first geometry test without knowing anything else. Because our first geometry test was just on similar figures. So similar figures, one huge part about it is solving proportions. So you guys will be set for next year. All right, so sometimes your proportions don't necessarily look like a proportion right away. But a couple people asked me problems like this in class, and I think this is kind of interesting. So we have p minus 5 equals r over t. Now, we want to solve this for r. So if we had to solve this for r, well, it's pretty simple. We would just multiply both sides by t. And remember, when we multiply this side by t, we're multiplying this entire side by t. So it gets a set of parentheses. So there would be a distribution if we were doing that. So that would be pretty easy. We'd get tp minus 5t equals r. And then we're done. Now let's say instead they want us to solve for t. Want us to solve for t. Well, a lot of people thought that what I could do is just multiply both sides by r. Whoa, I missed. There we go, kind of. All right, but look at what happens on this side. This r does not, what we call, cancel that r. what you actually get is you basically have r over t times r over 1. So this problem now becomes r squared over t equals all that stuff up there. So that's even worse. Now you have an r squared. We'll get into this later in the school year, but this starts to become a super big problem. It'll be solvable though. So multiplying by the numerator is not going to cancel the denominator. So we're going to do exactly what we did before. We're still going to multiply by the denominator. It just won't finish the problem for us right away. So on this side we have t times p minus 5. Notice how I didn't distribute right away. It's better to keep this as factors, two different factors for now. Equals r. Okay, that's not that bad. But we want it to be t on one of these sides. Well, the only thing that's going on with t over here is it's being multiplied by p minus 5. So let's go ahead and let's just divide by p minus 5. And we get t equals r over p minus 5. And there we've solved it. So this is kind of a proportion in and of itself. You could think about this another way, though. I'll give you a second to write this down. Second's about to be up. Another way of thinking about this is thinking about this p minus 5 as p minus 5 over 1. And I won't go through and do everything, but if we did do that, we would see that r equals t times the quantity p minus 5, which is one of the steps that we just did previously. But you can always write something over 1 and then solve it with these cross products like a proportion. Maybe that's helpful. You'll never need to do that, but sometimes it'll be helpful if you get confused when the variable that you're trying to solve for, t in this case, is on the bottom. All right, that's all I really wanted to say about that. You guys have some on your own problems, and I'll see you in class tomorrow.